Our topic for today is the difference between high and low impedance voltmeters. First, a couple definitions. A voltmeter, of course, is an instrument that measures voltage. As used by engineers, scientists, technicians, and electricians, volts is one of the modes that is available in the widely used multimeter. The voltmeter also appears as a bench-type AC-powered multimeter. Built into electrical equipment, it is known as a panel meter. It has largely replaced the old-style ammeter on the dashboard of your car. Impedance extends the definition of resistance to include capacitive and inductive reactance. Like resistance, this is expressed in ohms, and it fully complies with Ohm's law. The main difference, however, is that impedance varies with the frequency of the power coming out of the source, while resistance is not frequency dependent. Here is a typical multimeter, the very high-quality Fluke 287, which sells for about $500. To read volts, press the green on button. Then move the rotary knob to select the desired mode, in this case AC volts. Notice that the readout fluctuates either side of the 0.03 volts reading. This is puzzling to beginning students and apprentice electricians. It is known as phantom voltage, a consequence of the fact that the meter is auto-ranging and very sensitive. The fluctuating voltage is analogous to the noise floor we see in an oscilloscope or spectrum analyzer. The floating voltage is also a consequence of the fact that the probes are not connected to anything. Once you connect to a live source, the meter will lock onto it and cease fluctuating. The meter is trying to measure across a short span of free space. In this situation, it is incorrect to say that the meter is not picking up and measuring a signal. It is actually measuring a finite voltage, very close, but not equal to zero. The Fluke voltmeter is a high impedance instrument, meaning that the input circuit through the probes draws very little current from the source. We say that it does not load the circuit under measurement. The voltmeter is invisible. That is appropriate for sensitive electronic circuits, which would be disrupted, if not destroyed, by the greater amount of current imposed by a low impedance instrument. This solenoid voltmeter, the so-called wiggy, is a low impedance voltmeter. That is not always a bad thing. It has no batteries because it is powered by the circuit that it measures. When energized, the indicator pops up, showing 120, 240, 480, or 600 volts. The instrument also emits an audible buzzing sound, and it vibrates, which can be felt distinctly. This is great for low light and noisy locations. The wiggy should not be connected to a sensitive circuit or remain connected to house current for more than a few seconds, as the meter itself can be overloaded and damaged. Many applications lend themselves to the solenoid voltmeter. For example, to test a Gfci, connect the wiggy probes to the hot wire, black, and grounding conductor, green or bare. The high impedance meter does not draw enough current, 4 to 6 milliamps, to trip the Gfci. Thanks for watching. New videos are added periodically, so check back frequently.